Good morning everyone. Hope you all understand my first topic, the refraction of light that I discussed in my first video. So today I will discuss on the second topic, that is the language of chemistry. Before I start the topic, I just want to tell you that science is basically divided into three branches: physics, chemistry and biology. Today I will discuss on the branch chemistry. So what is chemistry? First come to the point, definition of chemistry, that is branch of science that deals with the interaction of particles of matter. So from the definition it is clear that matter is made up of very small particles which is called atom. And this atom may or may not have independent existence. And group of atoms, they form the molecule. And this group of atoms, they either of the same type or of different type. If the group of atoms are of same type, they are called molecules of the element, and if the atoms are of different types, they are called molecules of a compound. So from this concept we come to the point again, a different point, that is atomicity. What do you mean by atomicity? Atomicity is the number of atoms present in one molecule of any substance. Now, on the basis of this point, I just want to tell you that atoms from here comes atomicity, that is number of atoms present in one molecule of any substance. On the basis of this atomicity, if the molecules of any element I consider, then it is divided into number one, monoatomic. That means here the molecule is made up of one atom. Example, all the inert gases. Example is all the inert gases, that is neon or radon. All the inert gases, they are made up of one atom only. Number two, diatomic. Diatomic means here the molecule is made up of two atoms. Example, diatomic O2, oxygen, O plus O. Again, N2, nitrogen, H2, hydrogen. These are all the example of diatomic molecule. Next, number three, that is triatomic. That means it is the molecule made up of three atoms. Example, O3. Example, O3, that is ozone. After that come to the point, that is tetraatomic. Tetraatomic means the molecule, it is made up of four atoms. Example, sulfur, or sorry, phosphorus, P4, phosphorus. It is made up of four atoms of phosphorus. After that come, next is polyatomic. Polyatomic means it is made up of more than four atoms. Here see, example is SH, that is sulfur. Sulfur is polyatomic, that is it is made up of 8 atoms. So this is all the types, that is molecules of the same type, that is molecules of the element. Now come to the point, molecules of the compound. Atomicity of molecules of a compound. Just for example I am telling, H2SO4 This is sulfuric acid. Sulfuric acid. One molecule of sulfuric acid, it is made up of 2 atoms of hydrogen, 1 atoms of sulfur and 4 atoms of oxygen. So this is the, so what is the atomicity here? So atomicity here it is 2 plus 1, 3 plus 4 equal to 7. So this is the atomicity of the molecule of a compound, that is sulfuric acid. So first I will tell about the atom, that I will come to the point symbol. What do you mean by symbol? Symbol is related to atom. How? So first come to the point, that is definition of the symbol, that is symbolic representation of one atom of an element is called symbol. Who first invented symbol? This is the definition. The symbolic representation of one atom of an element is called the symbol. Who first invented this? John Dalton. John Dalton in 1803. He first represent, that is the diagrammatic representation of the atom of an element. First 1803 by John Dalton. According to John Dalton, the symbol of hydrogen, it is just like this. This one is hydrogen. This one is oxygen. Again, sulfur, just like this. This is sulfur. So this is all invented by John Dalton, but later on the scientist Berzelius in 1813 first replaced this concept and introduced the symbol of the element, or how, as the first letter of the element, or first and second letter of the element, first and third letter of the element, and fourth one is the from the Latin name. So come to the point first. Number 1, first letter of the element. First letter of the element. That is, suppose I am telling oxygen, symbol is O. Example, oxygen symbol is O, that means the first letter of the element. This is the first type. Number 2, first and second letter. First and second letter. Example, calcium, Ca. First and second letter, Ca. This is one example. Third one, is first and third letter. Example, magnesium. Mg. This is the first letter M, third letter G, Mg. And last one is very important, that from the Latin name. From the Latin name. Example, sodium. Symbol is Na. So from where the Na comes? The Na comes from the Latin name, that is natrium. Another example, potassium. Symbol K. Latin name Kalium. Kalium. So this is the last, that is from the Latin name. So in details you will get in your book. The table is there about the symbol, and this is the 4 types. Again I am repeating. Number 1, first letter of the element, that is oxygen, O. Number 2, I am telling first letter and second letter, that is calcium, Ca. Third one I am telling that first letter and third letter, that is the magnesium, M and G. And last one I am telling about the from the Latin name, that is example is sodium, Na, natrium, Latin name, potassium, K, Latin name is the kalium. So in gist, what significance you get from the symbol? Write the significance. Significance you get, number 1, name of the significance of symbol. What you get? Name of the element. Number 2, 1 atom of an element. And number 3, atomic mass of an element. So this is the significance of symbol. Now I come to the point, molecules. Important representation or the symbolic representation of a molecule of an element or compound, that is called formula. So my next topic is formula. My next I will tell about formula. Formula is nothing but symbolic representation of one molecule of an element or compound. This is the definition of formula. Now, according to the definition, molecule of element and this is molecule of a compound. This is the example you can see. Suppose O2, N2, H2. Here see, these molecules are made up of same type of atoms. That is the molecule of an element. O2, O and O, same type. N2, N and N. H2, these are all same type of atoms. Now see, come molecule of a compound. CO2, carbon dioxide, made up of one atom of carbon, one atom plus two atoms of oxygen. So it is clear that in case of molecule of a compound, different atoms are present, not same type. Here in case of carbon dioxide, one atom of carbon is present and two atoms of oxygen is present. Another example you can see. Nitric acid, HNO3. This is the one molecule of nitric acid, it is made up of one atom of hydrogen, one atom of nitrogen, and three atoms of oxygen. So this is called chemical formula. So what are the significance of the formula? Number one, it represents one molecule of an element or molecule of a compound. Number two, one molecule, that is chemical formula tells that how many atoms are present in one molecule. It is clear that just for example, one molecule of nitric acid, here one atoms of hydrogen, one atoms of nitrogen, three atoms of oxygen. So total 5 atoms are there. That is atomicity is 5. Total 5 atoms are. This is another significance, that from one molecule we can understand how many atoms are present in one molecule. And number 3, you can understand the molecular mass of any element or compound. So this is all the significance of chemical formula. Next topic is valency. Now I will discuss a very important topic, that is valency, or what do you mean by valency? So valency, two definition is there. Number one, combining capacity of one atom of an element is called valency. This is number one. Combining capacity of one atom of an element, that is called the valency. Just for example, I am telling H2O, oxygen here binds with 2 atoms of hydrogen. It is clear that one atom of oxygen binds with 2 atoms of hydrogen. So it is clear the valency of oxygen here it is 2. Number 2, suppose NH3. Here one atom of nitrogen combined with 3 atoms of hydrogen. So here the valency of nitrogen is 3. So this is the first definition, the combining capacity of one atom of an element. Now coming to the point, the second definition, number of electrons lose or gain from the outermost shell of an atom to attain its nearest stability is called valency. This is another definition. Number of electrons lose or gain from the outermost shell of an atom to attain its nearest stability is called the valency. Come to the point, that is example. Just for example, sodium. We all know that atomic number is 11. So electronic configuration 281. So outermost shell 1 electron is there. So now if this 1 electron sodium release it will attain stability. Now it becomes 28, and 8 we know, if 8 electrons are there on the outermost shell, that is the octet stability. How many electrons sodium lose? 1 electron. That means it becomes now Na plus. 1 electron it lose, that is why its valency is 1. This is positive charge ions. This is also called cations. any atoms having positive charge, that is called cations. Generally all the metals are cations, positive in nature. Another example, calcium. Atomic number 20. Electronic configuration 2, 8, 8, 2. Outermost 2. It will release these 2 electrons. Now it becomes 2, 8, 8 to attain the stability. So now it is called Ca2 plus. This is also another cation. So how many electrons calcium lose to become stable? 2 electrons. So the valency of calcium is 2. I think it is clear to everyone. Now another non-metals I am giving example. Chlorine 17, 2, 8, 7. Outermost 7. Now this chlorine, it will take 1 electron to becomes 2, 8, 8 and it becomes stable. Now as it takes 1 electron, it will become negative charge, that means Cl minus. It becomes negative, that means it takes 1 electron to attain stability. That is why the valency of chlorine is 1. And Cl minus, as it is negative charge, this is called anions. Positive charge is called the cations and negative charge is called the anions, and generally non-metals are the anions, that is negative in charge, and its valency is 1. So this is all about the basic concept of the valency. So after valency, my next topic is radical. What is radical? Definition of radical is that group of atoms of same type or different type having charge is called radical. Now having charge means either it becomes positive charge or it becomes negative charge. So if the radical having positive charge, then this is called basic radical, and if the radical contains negative charge, then this is called acid radical. Example, basic radical. If now see radicals, just now in the definition I tell same type or different type. If the atoms having charge and they are of same type, this is called the simple radical. And if the group of atoms they are of different atoms, then they are the compound radical. So just for example, see basic radical, this is positive in charge, this one is positive, and acid radical, that one is negative. Suppose H plus, Ca2 plus, these are all simple radical having basic charge, that is plus, positive charge. Now acid radical Cl minus, this is also simple radical but having negative charge, that means acid radical. Next is SO4 2 minus, this is sulfate, this one is sulfate. This is an example of acid radical. Just see, this is the compound radical as it is made up of 1 atom of sulfur S and 4 atoms of oxygen. So this is a compound radical and it is also acid radical, that is it bears negative charge 2 minus, that means its valency is 2. This also you will get details in your book, the table, the chart is there where you will get that is monovalent, divalent, trivalent, tetravalent and more than 4, that means polyvalent, that is either basic radical or acid radical. In your book there is table and you will go through the table, all you will get about the basic radical and acid radical. Now the last topic today, for today I will tell about the formula. Just now I tell that what is formula, that is it is the symbolic representation of one molecule of an element or compound. But now I will tell, this is the last topic that I will tell today, that is how you will write a chemical formula of any compound. chemical formula. If you write the chemical, suppose I am telling one compound, sulfuric acid. Sulfuric acid. How will you write the formula of sulfuric acid? See, first of all write HSO4. What elements are present in sulfuric? H, that is, this is the basic part, that is positive part, and this was the negative part, SO4 sulfate. Now write the valency here. Valency of hydrogen is 1, valency of sulfate is 2. Now just crisscross it. That means 2 will come here, 1 will come here. One, you don't have to write 1, just write there H2. So in this way you will write the formula of any compound. Again I am telling, first write the basic part, positive part, then write the negative part, second write the valency, their respective valency, third is just crisscross the valency and write the ultimate chemical formula of a compound. So another example is sodium carbonate. So write here sodium, first sodium is Na, carbonate CO3. Valency of sodium is 1, valency of carbonate is 2. Now just crisscross it. So it will become Na2CO3, sodium carbonate. So in this way you will write the chemical formula of any compound. So today till this much. On the next day I will discuss the last topic, that is the chemical equation and how to balance the chemical equation and why is it necessary to balance the chemical equation. So thank you for watching my video and please like and subscribe my channel Education World so that I can upload more and more education video like this. So today till this much. Thank you to everyone. Bye.